Hello students, myself is Parminder Singh from Prep Kripa classes. Our today's topic is DBMS Module 4. In this course, we will study about acid properties in DBMS, components of DBMS, relational database model, primary key, foreign key, and composite key. After going through this course, the students will understand that the full form of acid in DBMS is atomicity, consistency, isolation, and durability. The students will learn that atomicity means all or none. That is, either all the transaction has to be completed in full, or if any of the operations of the transaction fails due to any reason, the whole of the transaction is reverted back. The students will also learn that the database system has to be placed in a situation where it is in consistent state before and after the transaction. Isolation in DBMS means that in the case of multi-user environment, each transaction is performed in a way that it is isolated from other transaction and there is no interference between the transactions. Durability property ensures that if one transaction is complete, it is permanently saved in the database system. Even there may be some power problem or internet problem. Acid properties in DBMS are essential to maintain the data integrity and ensure that there is consistency of data. The students will understand that the various components of DBMS are DBMS software, DBMS hardware, then users, procedure, and database access language. The students will understand that the DBMS hardware includes storage devices and many other hardware devices. The students will learn that there are three kinds of people who interact with DBMS are database developers and database administrators and end users. Database access language provides the means so that we can interact with the database. The students will learn that relational database model was introduced by an English computer scientist E.F. Code in the year 1969, and it was introduced in 1970, and it has then since then become very popular in the field of database models. Then the students will also learn that there are many key components of relational model, that is tables, rows, columns, etc. The students will learn what is primary key, foreign key, and composite key. The students will learn that primary key cannot allow null values. Null values means values missing. Then the students will learn that a primary key in one particular table can appear in multiple columns as foreign keys. After going through this course, you will have a thorough knowledge about the acid properties which play a key role in ensuring the data integrity and data consistency of the system, and you will also understand how the relationship is established between different tables by way of primary key and foreign keys. Now our topic is acid properties in DBMS. The full form of acid is A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. These acid properties in DBMS are commonly recognized as fundamental principles of DBMS. All these four properties of DBMS collectively ensure that all the operations in the database are performed reliably and that the data remains consistent even in the presence of failures or concurrent transactions. It means that when many operations are being performed on the database, these acid properties ensure that database remains consistent even in the presence of failures. Failures means system failure, power failure, internet failure. Now we will discuss each of these properties one by one, and also we will try to understand each and every property with the help of real life example, so that we can not only understand the concept but also its usage in real life. So let us start the first, atomicity. Atomicity means either all or none. It means that either a transaction should be performed in full or all the operations of the transaction are reverted back. Now let us read. Atomicity is one of the acid properties in DBMS. Atomicity ensures that a transaction is treated as a single indivisible unit of work. Atomicity means that either all the operations within a transaction are completed successfully or the entire transaction is rolled back to its original state if any part of the transaction fails. We try to understand the same with the help of an example. Suppose you go to an ATM machine to withdraw money. You have to perform many steps. First, insert the card. Then you may be asked to fill your preferred language. You may be asked about your PIN. Then you may be asked what you want to perform on the ATM machine, whether you want to balance your check or you want to withdraw amount. Then after entering the amount, you may be asked how many amount you want to withdraw. That is, there are many operations within the single transaction. Either you want to withdraw money from the ATM machines or you want to check your balance in your account. So these are all the operations which are involved in a single transaction. So when there is, suppose, internet failure or power failure, then at whatever step you are, that is, either you are entering your PIN or after that you may be entering the account amount which you want to withdraw from the ATM machine. At any step, if there is failure, internet facility or power failure, the system will revert back to its original state. That is, you will have to perform all the operations again. We will understand this concept in more detail with the help of further examples. This property prevents partial updates. This property is crucial for maintaining the consistency and integrity of the data in the database. Now, we understand this concept of atomicity with the help of few examples. Suppose you are having an account in ABC Bank. This is you. And you want to send money to your friend B. Suppose there are $100 which are present in your account. That is the balance which is at present in your account. Here, friend is having $150 in his account. Now you want to send, say, $20 to your friend which is having account in the same bank. So now what will be done by the DBMS? It will deduct $20 from your account, and this $20 will go to the account of your friend and its balance will increase to $170. So if there is a system problem or system crash or internet failure or power failure at any of these steps, this is the whole transaction, and these are the two sub transactions or two operations of the single transaction. Now if suppose while $20 is being deducted from your account, it may happen that power failure may occur at this stage, or it may be possible that while your account has been debited, but when the transaction or operation was going on of crediting the amount to your friend's account, at this step there was failure of power failure or internet failure, and the account of your friend was not credited with $20. Then the Atomicity property of DBMS ensures that all this transaction is reverted back. That is, your account balance will be again shown as $100, and your friend's account will again have the balance of $150. That is, no credit, no debit. The debit which was performed on your account will be reverted back, and you will again have the original balance of $100. Now we take another example of airline reservation system. When you book your ticket for a flight, then this transaction involves some steps, that is reserving tickets. That is, you open the online site, you reserve the seat if the same is available, reservation of seat. After, when you click that I want this seat and the seat is available on the site, then the site will ask you to make payment. Then this payment will be deducted from your account, and then the system will, the website which you have approached will update the balance. Suppose here the balance of tickets in their online site was showing as only 50 seats are balanced, and you book only 2 seats. Then the DBMS system will ensure that 48 seats are balanced shown on the site. All this happens only because of the Atomicity property. That is, if there is, suppose while the system is going to reserve 2 seats for you, and you are making payment, and at this step, suppose when you are making payment, suppose there is some internet problem at your end and you are unable to make the payment, or you have not been able, or your bank has not been able to make the payment to the concerned website, then the DBMS system will ensure that the seat which was being allocated to you is reverted back to 50. It may be also possible that when the system was going to update the seats, it may be having some problem. Then if at any step, that is either at the step of reserving seats or making or deduction of payment or updating the balance seats, if there is any problem, the whole transaction is reverted back. Let us read. When a customer books a flight, the system has to take many steps, such as reserving seats if available, deducting payment from customer's account, and updating the remaining available seats. If all the 3 steps, that is reserving seats, deducting payment, and updating availability, are completed successfully, the DBMS ensures that the changes made by the transaction are saved in the database. If any step within the transaction, all these steps are represent the single transaction, encounters a problem or an error such as the system crash or power failure, the DBMS ensures that the entire transaction is rolled back, meaning that any changes made by the transaction are undone. Next is ATM withdrawal. When you approach an ATM machine for withdrawing cash, first of all, you will insert card, then the system will ask you your PIN number, and when you select the option that you want to withdraw the cash, the ATM machine or the system of the bank will check whether there is sufficient balance in your account, so that it may be able to cover the withdrawal amount. Suppose you may be having $10,000 in your account and you want to withdraw, suppose, $11,000. The system will say that you are not having the sufficient balance, so it may decline the transaction, or it may ask you to revise the option. If you are having, say, if you want to withdraw only only $5,000, the system will allow you. And after deducting the withdrawal amount from the account, your account balance is updated. That is, when you say that I want to withdraw this much amount from my account, the ATM machine will first deduct the amount, it will update the balance in its record, and after that it will dispense cash. If at any of these steps there is system crash, power failure or internet failure, the DBMS system or the Atomicity property of the DBMS will ensure that all the steps all the operations which have been performed in this transaction are reverted back. That is, you will be placed in the first position, that is from wherever you started. Atomicity ensures that if any part of the transaction fails due to a technical issue, network problem or any other error, the entire transaction is rolled back. Now we learn about or understand the second property of DBMS, and this is the consistency property of DBMS. It is also one of the important ACID properties. What is the meaning of consistency? Consistency means correctness of the database. It means that the database should be consistent before and after the transaction. We understand the same with the help of an example. Suppose you want to send money to your friend. You want to send $20, and after sending the amount to your friend, your account balance should be, we will write here. Suppose you are having $100. You want to send $20 and the balance in your account should be $80. On the other hand, if your friend is having $150 and you send him $20, the balance should be $170. That is, here the database is correct. That is, here 20 has been debited and here $20 have been made credit. That is, overall the position is the same. That is, if we sum up the balance of both these accounts, it means $250. And after the transaction, if we sum up the balance of both these accounts, it also means $250. That is, there is no consistency in the database. That is, it means that the system has not credited $10 or 15 or 30 or $50 to the account of your friend. It has debited the exact amount which was deducted from your account, and the credit of the same amount has been given to other person. Within the database schema, there exist integrity constraints and rules. These rules are essential for maintaining data accuracy. How this happens? How this consistency happens? For this, there are integrity rules or certain regulations which the DBMS system follows. These regulations are enforced consistently during the execution of the transactions. That is, at the each and every step of the transaction, these rules or constraints have to be followed by the system itself. We need not to worry about the technical aspects of DBMS. The DBMS system itself takes care of all these technicalities. This consistency property prevents any breach of these rules. These breaches could result in inconsistent database state. If there has not been the consistency property of DBMS, then it might have been possible that incorrect amount might have been credited to another person. Now we will try to understand this property of DBMS with the help of an example. We take the example of hotel. Suppose you have visited New York many a times, and one of the hotels is your preferred, say it is ABC Hotel. Suppose there are two persons or two customers, A and B, which want to book, say, room number 1. So the DBMS system will ensure that the two customers are not allotted the same room, or it may be possible that there is some renovation going on or in the hotel, or only a few rooms are there available for occupancy. The DBMS system will ensure that no room is allotted to more than one customer. That is, one room, one customer. And in case if it happens that is same room is allotted to two different customers, what will happen? There will be naturally customer dissatisfaction or dispute with the hotel, and it will earn a bad image for the hotel. Let us read what is written. Hotel room reservation. When customers make reservation for hotel rooms online, the DBMS ensures that no two customers are assigned the same room for the same dates. That is, both the customers want to book a room for the same date. Irrespective, we can say that room number 1 is not selected. They want to book any deluxe room. So the system will ensure that a particular deluxe room is allotted to only one customer and for a specific date. The database enforces constraints to prevent double bookings, maintaining consistency in room assignments. Next is the e-commerce orders. Suppose you are visiting Amazon site and want to purchase something. You place an order to purchase a PC. You have placed the order. Now, the DBMS system will ensure that suppose there are 100 PCs balance which are being shown on Amazon site. When you have placed the order, the DBMS system will ensure that when you have placed the order for one PC, the DBMS system will ensure that the balance inventory in their site or in their inventory should be 99. Let us read. When customers place orders online, the DBMS ensures that the items purchased by the customer is deducted from the online inventory and the quantity of products in the inventory matches the actual number of items physically available. It means that whenever a purchase is made by a customer, the DBMS system will immediately deduct that number of quantity of products purchased from the online inventory so that online inventory matches with the physical quantity available in the store of the Amazon. Now we take the third example of consistency in real life. Suppose there is a birthday function of one of your near and dear, and it has been decided that you will celebrate this function in some restaurant. You know the working of the restaurant which you have chosen. You go in advance to that restaurant and ask them that that a specified table be booked for them. It may also be possible that the restaurant you have chosen for dinner or celebration of the birthday function may be having online facility for booking of tables in that restaurant. In that case, the DBMS ensures that multiple customers are not assigned the same table. In case the restaurant is having manual system to allot the table to a customer, it may be possible that a similar table may be booked to different customers, because one customer may approach one partner of the restaurant and another customer may approach another partner of the restaurant. So in that case, conflict may arise. But in case of proper reservation system being adopted in the restaurants with the help of DBMS, this type of situation does not arise, because DBMS prevents such type of conflicts and helps in maintaining consistency in reservations. By enforcing consistency, the DBMS ensures the correctness of the database. Next, third property which we are discussing about DBMS is isolation property. Isolation property ensures that each transaction is treated as if it is the only transaction being executed on the system, and multiple transactions can execute concurrently on the database without interfering with each other. It means that though many transactions are taking place on the database at the same time, each transaction is acting as if it is the only transaction being done on the database. Each transaction must be isolated from other transaction until it is completed. Now we will try to understand this isolation property with the help of an example of an online bookstore where customers can purchase books. Suppose there is one last copy of a book which is in great demand, and the online bookseller has only one copy of the same, but the customers are many who are approaching the site. Suppose in this case only two customers, A and B, are approaching the site for the purchase of one particular book which is available in single quantity, that is only one copy of that said book is available. Suppose A customer approaches the site by milliseconds ahead of B. That customer chooses the book he wants to purchase, he makes the payment, and the said book is allotted to or booked in his name. At the same time, was also trying to purchase the book, but the system, DBM system, places a lock on the transaction which is being done by A. That is, when the transaction of A completes, only then the B the transaction starts. That is, we have already learnt about the isolation levels of in DBMS. That is, read uncommitted, read committed, repeatable read, and serializable. Suppose in this case of bookseller, the isolation level used in DBMS is the highest level, that is the serializable. In that case, though A and B are simultaneously trying to purchase the same book, then the DBMS system will ensure that the transactions are to behave as if they are in serial order, that is in queue. That is, one transaction is in queue. After that, when the first transaction completes, then the second transaction starts. Now we will try to understand the situation or the example with the help of what is written. Concurrency. Customer A and B both initiate transaction to buy the last book in the inventory. These transactions are executed concurrently. Concurrently means at the same time. The DBMS system which is being used by the bookstore implies isolation levels to manage the concurrent transactions. Let us say the isolation level being used by the bookseller in his DBMS system is serializable. That is the highest level, strictest level of isolation is being used in the DBMS. We have already learnt about these 4 isolation levels in our previous course in detail. We have also learnt about the read lock and write lock. You can also learn about the same from our previous course. When the customer A's transaction begins, the DBMS places an exclusive lock on the book inventories record to prevent other transactions from modifying it. That is, when the transaction of A is going on, the DBMS system puts a lock on the inventory of the book. That is, no other person can place the order for the said book. Customer A's transaction proceeds to completion, deducting book from the inventory. When the A has purchased the book by making payment, A's transaction is complete, and when the order stands placed, the inventory which is being shown online will be deducted. That is, if there was only one book, the same will be deducted from inventory and the zero balance will be shown. Next, transaction for customer B. At the same time, customer B's transaction also starts. However, since the book's inventory record is locked by customer A's transaction, customer B's transaction temporarily held in a queue because the customer A's transaction has started slightly ahead in time, say by milliseconds. Customer B's transaction waits until the exclusive lock is released and inventory record is available for update. That is, the DBMS system will not allow the B to proceed with this transaction. When A's transaction completes and the exclusive lock which was put by A's transaction has been removed, only then the B will be able to proceed further with his transaction. This ensures, that is, this locking of the inventory record ensures that customer B does not buy the book that has already been sold to customer A. Once the lock on the inventory record is released after A's transaction completes, customer B's transaction is allowed to proceed. If the book is still available, that is, if the number of books have been 2, say 2, then one book will be available. The transaction deducts it from the inventory. B will be able to make the payment and this said quantity will be reduced from the inventory. By using isolation mechanisms, the DBMS ensures that concurrent transactions are managed effectively, avoiding scenarios where the same book or item could be sold to multiple customers due to simultaneous purchases. It means that when multiple purchases we are making on the online sites, if there was no isolation property of DBMS in force, then the situation would have arisen that the same item would have been sold to many customers. Suppose there were only 10 items which were available on the site. If the isolation property was of DBMS was not there, then it may be possible that only 10 quantity items might have been sold to say 100 customers due to simultaneous purchases. Simultaneous means concurrent transactions, as many persons will be approaching this site for purchase of say one particular item. The same product could have been sold to many customers, resulting in customer dissatisfaction because all the customers would not be able to get the same, as the quantity available with the site was only limited. It ensures a smooth and accurate online shopping experience for all users. So it ensures that the online shopping experience for customers is good. Now the next acid property of DBMS is durability. Durability ensures that once a transaction completes, the changes made by that transaction are permanently saved to the database, and these changes survive any subsequent failures such as power outages, system crashes or system failure. It means that once you have completed your transaction, say A has purchased his book, he has made the payment, and the message has been received from the online site that particular order has been confirmed. Suppose in the meantime power goes off or internet failure occurs, internet connection fails, even after or system crash occurs at the level of say online site, even after that the DBMS system has the mechanism that it will ensure that the inventory level which is being maintained at the database of the online site is properly updated. Suppose there were 100 products available, and after you're having purchased one item, 99 products would be shown on the site when the system restores, because the DBMS system ensures such type of feature because of having adopted many procedures to ensure that the correct inventory is shown even in the case of system failure, power outages, etc. Let us read what is said written here. Sometimes it happens that the transaction is incomplete at the time of failure, and the changes made by these incomplete transactions have not been committed. Committed means saved to the database. It means that transaction is suppose going on. There are many operations which have to be performed in the transaction. When the transaction is still not complete and the power goes off or system crashes occur. So when the transaction is incomplete and all the changes have not been committed to the database, committed means changes have not been recorded in the database, then the system will ensure, DBMS will ensure that all the transaction is rolled back to the original situation. So all the changes made by the incomplete transaction will be reverted and will not affect the state of the database system, that the database system will be restored in its original position. For example, imagine you are using an e-commerce platform to place an order for a product. When you finalize the order, a transaction is created in the database to reduce the product's stock quantity and record your purchase. It means that when you have placed the order, you have made the payment. Payment has been made by you, order has been booked, and in the meantime, power goes off at the level of online site. When you have purchased the item, then the DBMS system has to ensure that the quantity purchased by you has to be reduced from the inventory of the online site. So when the inventory was to be updated, the power goes off or sudden server crash occurs. If there was no DBMS property of durability, that is, there was no asset property of durability in DBMS, it would have been possible that the order was confirmed to the client and at the same time inventory level might not have been reduced. Without the durability property, there is a risk that the stock reduction might not be saved due to the crash or power failure. This could lead to issues such as overselling products and disappointing customers. Now, the durability property comes in action. Thanks to the durability property of DBMS, when the system is restored after the crash, it ensures that the stock quantity has indeed been reduced as per your order. Even though there was a momentary interruption during the order processing, the database maintains the accurate stock level, preventing potential stock related problems. The example given above demonstrates that durability is an important feature of DBMS, which ensures data accuracy and system reliability, particularly in cases of e-commerce where product availability and inventory management are important. Because in the e-commerce, if there is mis-selling or selling of a product which is not available actually in physically in the inventory or the stock of the online site, it will result into large scale customer dissatisfaction. So here the durability property of DBMS comes into play and ensures that such type of situations do not arise. Now, how the DBMS system ensures durability? That is, when the failure of the power or system crash has occurred, though the order has been confirmed to the client, how the system ensures that the inventory level is updated even after crashing of the system or power failure? Some of the techniques used by the DBMS to ensure durability are write ahead logging, redo logs, and transaction journaling. These techniques collectively contribute to the durability property of DBMS. That is, these techniques collectively play a role to ensure that this system properly shows the accurate items and that the committed changes are reliably preserved even in the face of unexpected system disruptions. In conclusion, we can say that these asset properties of DBMS are very important for ensuring data consistency, integrity, and reliability in databases. Atomicity guarantees the all or nothing execution of transactions, that is all or none. Consistency ensures the database transitions from one valid state to another. Isolation lab prevents interference between concurrent or simultaneous transactions, and durability property safeguards data changes against system failure. These properties collectively make DBMS a reliable and efficient tool for managing data in modern organizations, where the organizations have to deal with structured data, semi-structured data, object-oriented data, graph data, etc. Now the topic before us is components of DBMS. From this picture, you can see the components of DBMS which we will be discussing about are software, hardware, data, users, procedures, and database access language. We will discuss each of these components one by one. First is software. Here we are not talking about the general software which we normally refer to in our computers. Here we are talking about actual DBMS software that facilitates data management, storage, retrieval, and manipulation. Manipulation means inserting of data, updating data, deleting data. The software components of DBMS include database engine, query processor, transaction manager, data storage manager, etc. Next component of DBMS is hardware. The physical infrastructure that supports the DBMS software includes servers, storage devices such as HDD, SSD, and networking equipment. Hardware can be costly depending on the configuration. The maintenance cost of hardware is also high. Now the third component is which we are discussing is DB data. It is not a physical object. It is a collection of facts or figures that can be used to represent something. The main purpose of DBMS is to process data. Most of the organizations generate, store, and process large amount of data. For example, in the case of online sites such as Amazon, eBay, millions of customers approach their site for various types of products. They may be updating their personal information or searching for some products, placing order for the same. So the DBMS has to ensure that all such type of data is properly managed and processed. They have to store, the DBMS system has to ensure that all this data is properly stored and managed and retrieved as and when required. Database contains both the actual or operational data and the metadata, that is the data about data or description about data. Next is users. There are three kinds of people who interact with the DBMS. First is developers. Developers are involved in developing and designing the parts of DBMS. Then comes database administrators, who are responsible for administrating the database. As you know that in any organization, there may be many employees working in an organization. We take the example of a bank in which there are many employees. Some performs the function of cashier, other may be associated with the function of loan disbursement, other person may be dealing with saving account or current account or fixed deposit accounts. That is, all the persons may have different duties, and overall above all there is a branch manager in charge of the specified branch. Then all these persons have different types of roles to play, whereas a loan officer has to take care of the how many customers have obtained loans, whether they are paying in properly. On the other hand, the person dealing with saving or current account has his own role to play. So the database administrator has to ensure that all these persons are given access to the data on the basis of their roles. In the case of branch manager, he may be having access to the data of the whole branch. That is, how many accounts are there, whether saving, fixed deposit, current account, loan accounts, whether the performance of the branch is improving or not. Whereas a one step higher, that is the regional manager of the bank, may be having many branches under its control. He has the authority in the DBMS to see the working of large number of branches. He has access to the data of many branches. So database administrator has to ensure how much access has to be given to a particular person. This access of data may be time based or role based. Time based means if a employee may be having shift duty, that is one person from 6 to 6 in the evening morning duty, and other person may be having 6 to 6 night duty. That is role based access, time based access. And how and who should be allowed the to have access to the database? That is, they have to be provided with username, password, or two-factor authentication. So all these type of, that is, who is to be given access, how much access to be given, all these type of decisions have to be taken by database administrators to ensure that there is no unauthorized access to the database. Then the other persons who interact with the DBMS are end users. End users are those who interact with the DBMS. They conduct various operations on the database like retrieving, updating, deleting, etc. Next component of DBMS is procedures. Procedures means the rules and instructions that help us to design the database and how to use the DBMS. These procedures include to log in and log out of the DBMS software. That is, what procedures is to be adopted, how we should have access to the DBMS. And then the procedures may include how to manage databases, how to take backups, that is, whether the backup is to be stored in the online site or to a site which is away from the database server, main database server, or the backup has to be made in some cloud server. So these are all the procedures. And then generating reports, that is how, which type of reports are essential, such type of are the all procedures. Then the database access language. the language used to communicate with and manipulate the database such as SQL. Now the topic before us is a relational database model. The relational database model is a database model. It was introduced by E.F. Cobb, an English computer scientist, in the year 1969. And this model was formally published in June 1970. It has since become one of the most widely used database models. A relational model is based on the idea of organizing and representing data in the form of tables which consists of columns and rows. Suppose this is the table. Where these are the rows and these are the columns. Suppose you are having an online site and the relational data will be maybe consist of customer ID, customer name, email or contact number. So each row, here we can say that this is A, B customer name, C, D. This is the email ID of Gmail. Here it may be having Ymail. Here these are the contact numbers. So each row, that is this row, each row represents a record, and each column, this is the column, represents a specific attribute or characteristic of the data. That is, each column represents a specific characteristics of the data. That is, here as the table shows the employee data, customer data, so here this column is representing the email of each customer. The relationship between tables is established through keys. Suppose there may be some other table, say order table, where the orders placed by different customers are recorded. Here it will be order ID. Then it may be order item. Then it may be customer ID. So the relationship between tables is established through keys. Here you can see that here it is the customer ID in one table, customer table. This is the order table. So this table is related with this table in the form of keys. Here it is the primary key, it is the secondary key of another table, foreign key in another table. The relationship between tables is established through keys, which are used to link related data across tables. We will have a clear view of these tables when we proceed further with this course. You will understand the concept of primary key, foreign key, composite key in detail, and a clear view of each of these tables, so that you can clearly understand the concept in a very simple manner. Here are some of the benefits of relational model. It is easy to understand and use, flexible way of organizing data. It is very efficient way of storing and retrieving data. This is because the data is stored in the form of tables which are easy to index and search. The relational model is a reliable way of storing data. Now the key components or key concepts of relational model. Now first is tables. Tables are also known as relations. It is the essential and primary element around which the entire relational model is built. In the relational model, data is organized into tables known as relations. Table consists of rows and columns. Rows are also known as tuples and columns are also known as attributes. Each table has a unique name. For example, we may be having a table called customers table, and customers table may have different columns such as customers ID, name, email ID, address. Table represents entities or concepts in the real world such as customers table, products table, employees table, orders table, etc. Suppose many employees working on in an organization. In the table given below, the information about each employee is stored in a row or record. Here you can see that there is an employee Mukesh. He has been allotted employee ID 567. Here you can find that his date of birth is given here and his contact number is this. So this is the record about a one particular employee Mukesh. In the same way, we are having a complete record about a particular employee Rihana in some another row. So information about each employee is stored in a row. This table has 5 columns. 1, 2. Here it has 4 columns. 4 columns and 5 rows. 1, 2, 3, 4, 5. These are 5 rows. The table shows that all the records in a spreadsheet format. All these records are in spreadsheet format. A table is a collection of data organized in columns, that is fields. These columns are also known as fields. The rows are also known as records. The top row in the table is reserved for field names. This is the uppermost row in the table. This is reserved for field names. That is what type of information we are to add here. Here it is mentioned. We are not to write in this field anything. We are to mention or keep the record in our subsequent rows. Next, rows. Rows are also known as tuple. It represents all of the data or information about one person or entity or anything. If we are having customers table, then all the information about the customer will be mentioned in the row. If we are having employee table, then all the information about a particular employee will be mentioned in the row. Each row in the table has same structure. In the database terminology, each row is also known as a record. In the customers table, a row would represent information about a specific customer. That is information here. Information has been given about John. His customer ID has been given. His email ID has been given. Each tuple is uniquely identified by a primary key. Here you can see that this is the customer ID. This is the primary key. We will understand about the primary key in detail in subsequently. Now columns. Here you can see that these are columns. 5 columns here have been shown, and the columns are also known as attributes, which are the characteristics of the entities being modeled. It means that when we are talking about customers or customers table is being maintained, all the columns will be pertaining to the customers. If we are having employee table, all the columns will be talking about or having record or data about employees. For example, in the employees table, columns could be employees ID, employees name, age, address, salary, etc. Only a specific type of data can be stored in these columns, such as text. For example, here you can see that in the case of employee ID, here numbers have been given. In the case of name, we are not writing 1, 2, 3. We are having specific names, Mukesh, Shelly, Rohit, etc. In the case of age, we are writing the completed years. We are not writing the year in which he was born, 1970, 1st Jan, 1970 or 2nd Feb, 1982. We are not writing in this way. We are writing only the completed age in years. Here, this is the address. Here we are not writing the address 1, 2, 3, 4, 5, 6, not pin code. We are writing the specific location or specific city or specific country or specific state in which a particular customer is residing or having office address. Then here it is the mention of salary. Here it is in numbers 1, 2, 3, 3, 4, 5. Address may consist of text data or a combination of numeric and text data. It may be possible that in the case of address, it may be written as 1, 2, 3, say Garden Colony, New Delhi. So here you can see that these are the numeric figures, that is the numbers, and here Garden Colony, New Delhi, it is the text. So the address may consist of text only. Here you have seen text only, or it may consist of numeric plus text. Now, primary key. Primary key is a unique identifier for each table or each tuple or row within a table. Suppose there is a university or school in which a large number of students are studying. There may be many persons having the same, many students which may be having the same name. For example, we may say Mukesh. It may be possible that there may be many Mukesh in the school. Even if we talk about a particular class, say 10th class, it may be possible that there may be 3 students having the name Rakesh. So how to recognize when the teacher wants to, when the teacher says Rakesh stand up, all the 3 students will stand up. So here we have to allot a specific student ID to a particular student so that the teacher or the school authorities can easily recognize a particular student. So primary key is a unique identifier for each row within a table. In the case of customers, there may be many customers which may be dealing with a particular shop, but the customers may be having the same name. Here again the customer ID is allotted, which serves the purpose of primary key. In the customers table, customers ID column could serve as the primary key. Keys are used to establish relationships between tables. We will learn how the relationship is established between tables. Next is foreign key. Foreign key is a column or a set of columns in a table that refers to the primary key of another table. It establishes a relationship between 2 tables. As already told, suppose there is a table, say customers table. Here customers ID is given. Here customers name is given. here contact number is given. It is the customer table. Suppose the customer place order. Here it may be orders table. Here it is the orders ID. Or order date. Here may be customer ID. So when this is the primary key and it is having relationship with the order table in the form of foreign key. When the order is placed, order is recorded here, and here mention is also made about the customer ID, so that we can judge or we can verify that which customer has given the order. So this relationship between two tables, that is the customer table and the order table, is established by way of primary key and foreign key. So here foreign key serves the purpose of relationship with the another table. Here in the order table, this is the primary key so far as the order table is concerned. But in certain situations, it also happens that one primary key, that is this key, is not sufficient to uniquely identify a row. For example, in a single class, roll number is enough to find a student. That is, we may be having 40 students and each student has been allotted a roll number, say 1 to 40. And when the teacher asks for, say, roll number 20, roll number 20 will stand up. 25, 25 will stand up. But in the whole school, there may be many classes and each class may be having 1 to 40 students or 1 to 20 students. Then if we say roll number 20, there may be many students across many classes having the same roll number. Then in that case, it becomes difficult to find out a particular student. So in the entire school, finding a student solely on the basis of roll number is not enough, because there may be many classes in the school and each one of these classes may be having the same roll number. So to uniquely identify the student in such cases, we have to say something like that, class 8, roll number 6. So here class 8 plus roll number 6 constitutes the composite key. That is, two keys come together, two characteristics come together and form the key, which is the composite key, so that we may select a particular or recognize a particular student. Next is normalization. It is the process of organizing data in a way that minimizes redundancy. Redundancy means duplicacy, and ensures data integrity. It involves breaking down large tables into smaller related tables to eliminate data anomalies. Next is integrity constraints. Integrity constraints are rules that define permissible values and relationships within a database. Constraints specify rules or conditions that the data must specify. Examples of integrity constraints include primary key constraints, foreign key constraints, unique constraints. They ensure the consistency of data and prevent invalid data from being stored. We take the example of foreign key constraint. When an order is placed and order is recorded, then employee ID has also to be customer ID has also to be put in the database while recording the data, while recording the order. So when we are entering the customer ID who has placed the order, the DBMS system ensures that the customer ID which is being mentioned in the order ID is actually existing in the database, that is, it actually exists in the customers table. That is, the system or DBMS system will not allow that an invalid customer ID is mentioned in the order table. That is, we are not having, say, customer ID 1234. We are having only the customer IDs up to 1000, and the DBMS system will not allow to place the order in the name of customer ID 1234, which is actually not existing in the customers table. In the same way, there are other unique constraints. We take the example of unique constraints. Suppose there is a bank where customers come for opening different type of accounts, say saving account. Suppose 2000 accounts have been opened till date, and now another customer comes, he opens his account. Now the DBMS system will ensure that this new customer is allotted another unique account number which has not been already allotted to another customer. That is, this system will allow him 2001 because 2000 numbers have accounts up to 2000 have been already allotted, and the system will not allow that any number between 1 to 2000 is allotted to another new customer. This is the unique constraint. They ensure the consistency of data and prevent invalid data from being stored. That is, these type of integrity constraints ensure that there is proper data is saved and invalid data is not stored in the system. Primary key constraint ensures that each value in the student ID column is unique and not null. Here you can see that all the student IDs are unique. No ID is similar to another one. Foreign key constraint ensures that each order is associated with a valid customer. Here this is the primary key. Here it is the foreign key. Both these accounts tables are related with one another with the help of primary key and foreign key. So foreign key constraint ensures that each order is associated with a valid customer. You can see that this is the customer ID which is mentioned in the order table. So this customer ID is existing in this customer base, customer ID base. That is the customer table. This ID is existing. If you say that there are only customers which are up to C65,000, up to this data, up to this customer number, customers are existing, customers are on the roll of the particular organization. If while placing order, the employee of the organization mentions the customer ID, say as C67,001, the system will not allow the same because no proper record of the same, that is, no record of the same will be existing in the customer table. That is, no such record will be available in the original customer table. So the system will not allow such type of invalid data to be entered in the system. This is the foreign key constraint. Next is data integrity. The relational model enforces data integrity by adhering to certain rules, such as ensuring that each value in the column is of appropriate data type and foreign key references are valid. It means that we have already mentioned that when we are talking about the tables, in the case of say employee ID, if the IDs are in the form of 1, 2, 3, 4, 5, all the IDs will be in the similar name. That is, we will not be able to enter text here. If we are talking about name, the same will be in text, say Mukesh. Here we will not be able to enter 1, 2, 3, 4 because it will be in text base and not in numbers. So each value in the column is of a appropriate data type. Next is structured query language. It is pronounced as SQL or sometimes SQL. It is the programming language used to interact with the relational databases. SQL allows users to create tables, retrieve data from tables, insert new records, update existing records. That is, it helps the user, structured query language helps the user to do various types of works and perform various operations in the relational databases. Now comes the ACID properties. We have already discussed about the 4 ACID properties of DBMS, that is atomicity, consistency, isolation, durability. The relational model supports the ACID properties which ensure that the reliability and consistency of database transactions. These components define how the data is structured, stored and managed within a relational database system. Relational database model is a very powerful way of organizing data. Relational model is easy to understand, easy to use, and it is very efficient for storing and retrieving data. This model has become most widely used database model in the world. It is the foundation of many popular database management systems such as MySQL, PostgreSQL, and Oracle database. Now the topic before us is primary key, foreign key, and composite key. Suppose there is an organization in which say 100 employees are working. There may be many employees which may be having the same name. Suppose we take the example of this organization where many employees are working. Say here 2 employees are working with the same name, John. When you want to identify or want to call one particular employee, say John, whether you will say John who is having salary of $25,000 or you will say call John who is having salary of $26,000. No, you will not say so. So here to recognize or to pinpoint or to uniquely identify a one particular employee, we allot employee ID to each employee so that we can uniquely identify a particular employee. So here in this case, we may say allot employee ID 204. So here when we are to uniquely identify a particular employee, we may say employee ID 203 Ramesh. That is 203 will be sufficient employee ID to recognize a particular employee. So let us read. A primary key is a unique value that identifies a row or a record in a table or database. Here this is the primary key which is identifying a particular record pertaining to one particular employee. In the same way, if we are talking about customers, then customer ID will serve the purpose of primary key, and we will be able to recognize all the attributes pertaining to one particular customer. What is his name, what is his address or contact number. Every single record in the database, this is the single record, this is the single record, this is another single record. Every single record in the database has something to uniquely identify it, and this is called primary key. Here in this complete row, this particular thing is unique. This is unique. On the basis of that, we can recognize, because many employees may be having salary of say 25,000, some may be having similar salary of 40,000. So these are not unique values. Names may be also similar, salary may be similar. So here in this case, employee ID serves the purpose of primary key. One column in each table acts as primary key. Relational databases use primary keys to establish relationships and connect records between different tables. For example, employee ID is the primary key of the employee table. When you got admission in a school, you were given a student ID, that is primary key. When a patient gets admission in a hospital, he is given a patient number, that is primary key. This means that any treatment which is given to the particular patient is recorded accordingly in his record, and he is given the right medicines. A primary key cannot allow null values. What is the meaning of null values? Null values means the value is missing or unknown. If the null values are allowed, that is, if we leave this student ID black, or we do not know it and we write it, will fill further items, further things are entered, whether we will be able to fetch the record on the basis of this name Tina, because there may be many students with the same name which may be studying in this school. So the primary key cannot be null. It cannot allow null values. We have to allow some particular ID. That is in the case of primary key, we have to mention some relevant values, unique values. If null values are allowed, multiple records could potentially have the same null value in the primary key column. That is, if it is allowed that in the case of student ID, null values are allowed, or in the case of primary key, that is student key, null values are allowed, then many students may be given the null values. That is, they may not be given any number, and the admissions will be made, and it will become very difficult to recognize a particular student at a later stage. Primary key can consist of both numbers and text. It is not that when we are talking about the customers or employees, we may say that this is the customer ID or this is the student ID, that numbers alone. It may be possible that primary key can consist of both numbers and text. That is, we can say that customer is C12345 or employee ID is D53241. In the same way, in the case of book ID, the book ID may start with this B and then with numbers, then A, and then numbers 10234. Each value in the book ID is unique, which is a requirement of a primary key. That is, two books will not have the same ID. Each book will have its own specific value. book ID, which is separate or unique from other books which are available on the online store. Next is composite key. When primary key is made up of two or more columns, then it is called composite primary key or compound key. Composite keys are used when a single column cannot uniquely identify a record on its own, but a combination of columns can. How? Because there may be instances that in a particular organization, a particular student may be studying different courses. Suppose a educational institution is offering different types of courses, and there is no restriction that a particular student can join only single course. A single student can enroll himself or herself in many number of courses. So in that case, student ID plus course ID together will serve the purpose of composite primary key or composite key, so that the particular student is uniquely identified. The table represents the enrollment of students in courses. A combination of student ID and course ID could be a composite key, since a student can be enrolled in a multiple courses and different students can be enrolled in the same course. Foreign key. When a primary key from the first table, this is the first table, that is the student table, is used in the second table to locate or look up records from the first table, it is called foreign key. Now here you can see that this is the in the course table, this is the primary key C001. Now when this course ID is appearing in another table, that is the student table, it is acting as course ID, that is this student is enrolled in this course. Here only course ID is given, and this course ID represents the type of course in some another table, that is the course table. A foreign key in one table points to a primary key in another table. Here it is the foreign key, course ID. It is having its relation with another table, course table, where it is appearing as course ID, creating a connection between two tables. So here the established between two tables has been established by way of primary key and foreign key. In the one course, this same thing is appearing as foreign key. In another table, it is appearing as primary key. Course ID column of the student table works as a foreign key as well as a primary key for the course table. You can see that course ID is working as primary key in one table, and in another table it is appearing as foreign key, and the relationship between the two tables, that is the course table and student table, is established by way of this primary key and foreign key. A table may have multiple foreign keys, and each foreign key can have a different reference table. Let us see how it happens. Consider an online store. Here order contains multiple foreign keys. Here you can see that orders are being placed one by one, and each order is assigned one number. Suppose say order number 1, order number 2, order number 3. Here the on the basis of the orders, customer IDs are also being recorded online by the system. Accordingly, which product they are purchasing product ID is added, order date is added. So here you can see that customer and products, here these are the customers, these are the products. Here in the case of customer ID in the foreign table, a order table, you can see that in the orders table customer ID, order ID is the primary key. This is the primary key in case of orders table, whereas customer ID is the foreign key. It is appearing as primary key in another table, in the customers table. Product key, which is also a foreign key in the orders table, is appearing as primary key in the products table. So you can see that this is the orders table which is having two foreign keys, customer ID and product ID, which pertain to some another table, that is the customer table and product table respectively, where the customer ID and product ID are appearing as foreign key, and it shows which customer has placed the order and the order has been placed for which product, and this type of relationship is established by foreign key. Here is an example where a primary key from one table is used in another two tables as foreign key. Student ID, you can see here that these are the student IDs in case of student tables. Now you can see that student ID from students table is used as foreign key in both enrollments and grade tables. These are two another tables. You can see that enrollment table and grade table. Now you can see that student ID is also appearing in enrollment table. Student ID is also appearing in grades table. Course ID is also appearing in enrollment table, and here it is also. So you can see that student ID, this is the foreign key in, this is the primary key in students table. It is appearing as foreign key in enrollment table and also as a foreign key in grades table. This is the foreign key. In the same way, course ID, this is the course ID from the course table is appearing as foreign key. This is the course ID. It is appearing in this table as well as in this course. Here it is the primary key and it is appearing as foreign key in this table and also in this table, two tables, another tables, it is appearing as foreign key. So the primary key is one and it is appearing in different tables as foreign key. Primary key 1, two other tables foreign key. The table containing foreign key is always the child table, and the table that provides the primary key is always the parent table. That is, where the primary key is present, it is known as parent table, and where the foreign key is there, it is known as child table. So this can be memorized as one parent PK, many child FK. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.